Welcome to this explainer. Today we are diving into a totally mind-bending paradigm shift that challenges, well, basically everything we think we know about reality. What if the bizarre, almost magical rules of quantum mechanics aren't actually physics at all, but a literal hardware glitch hidden right beneath our screens? Let's get right into it and start defeating quantum woo.
You know, for decades, the absolute brightest minds in physics have validated our profound confusion over the quantum world. Richard Feynman famously said nobody understands it. Even Albert Einstein famously decried quantum entanglement as spooky action at a distance. For the longest time, we've largely just accepted that the universe acts in these bizarre, magical ways we simply can't comprehend.
But what if there is no quantum woo going on here? The research we're exploring today proposes a totally staggering alternative. What if this spooky action isn't some mystical property of the universe at all, but rather an epistemic illusion? A literal blind spot caused by the limitations of our very own observation hardware.
To really grasp this matrix-style glitch, we have to strip away the software completely and descend all the way down to the silicon metal. We need to meet the real antagonist of absolute mathematical reality, the floating point unit, or, as we'll call it, the FPU gambler.
Think of the actual physical universe as operating on infinite, continuous exact math. It's like a vast, limitless flowing ocean. But our FPU gambler, it is strictly limited by its hardware register width. It's forced to squeeze that massive, infinite complexity into fixed, arbitrary hardware bits. It's essentially like trying to force that entire ocean through a tiny garden hose. It literally has to irreversibly erase information just to make it fit.
Okay, so let's dive into how this actually happens. To process super heavy math at blistering speeds, the FPU gambler constantly drops tiny, trailing fractions in a microscopic rounding error. Researchers call this the 23rd bit chop. Because it can't process the whole number, it relies on secret, proprietary corporate seed tables burned into the silicon to literally just guess the answers. It sacrifices perfect accuracy just to keep the machine moving.
Now, this chaotic guessing triggers a total chronological disaster that researchers call the wood chipper effect. The exact source data goes in, that 23rd bit chop completely shreds it to approximate the math, and boom, the data's original provenance, its true mathematical path, is permanently destroyed. You absolutely cannot go backward.
The source material uses this brilliantly simple metaphor here. Think of the FPU as a giant digital blender. You might know exactly what exact fruits you put in, right? But once that hardware starts approximating and blends it all up, you absolutely cannot reverse engineer that smoothie back into its original exact ingredients. This one-way destruction causes what's called non-deterministic drift, which is basically just invisible errors snowballing and compounding the longer the system runs. And just to give you a concrete anchor for how massive this crisis is, an estimated 80 to 90% of modern AI compute cycles are currently relying entirely on this blurry hardware guessing rather than exact arithmetic. Our most advanced models are built on a system that's, mathematically speaking, literally just throwing darts at a board.
So, you might be wondering, what does this all mean for quantum physics? Well, this exact hardware limitation completely demystifies the great quantum observer paradox. If we look at entanglement through the lens of this bounded hardware, all that magic just vanishes. We can literally reframe quantum entanglement as nothing more than a structural rendering glitch of reality.
The research calls this specific glitch topological aliasing. It's essentially a massive epistemic illusion. Think of it like trying to play a highly detailed 4K video game on a tiny 20-year-old monitor. The hardware just doesn't have the bandwidth, right? Because our observation hardware has these strict limits, a single incredibly detailed point of information gets mapped out as a glitchy, multi-valued projection.
And this is exactly where the illusion happens. Quantum entanglement is just an epistemic illusion caused by the FPU gambler failing to reconcile extremely fine-grained, discrete lattice mantisses. When it tries and fails to process that level of detail, the observer's finite complexity budget is totally blown. Imagine folding a piece of paper and shoving a pencil through it. When you unfold it, you see two distinct holes, right? That is an aliasing fold. So what we think are two entangled particles is actually the exact same informational node experiencing an aliasing fold when projected into our 4D space. The spooky action isn't magic at all, it's just a strict artifact of our finite hardware.
The weirdness isn't in the physics, guys, it's in the rendering. So to cure this illusion and build digital systems we can actually trust, we have to make a huge shift. We have to implement the deterministic solution of topological aliasing on the exact ALU surveyor.
We fire the chaotic dart-throwing FPU gambler entirely and bring in our deterministic hero.
The arithmetic logic unit, or the ALU, is essentially a precision laser. It is completely blind to those messy approximations. It is fully, beautifully deterministic. It guarantees that 1 + 1 equals exactly 2 on every single machine on Earth, every single time, without exception.
Unlike the gambler, the surveyor deals strictly in absolute hardware truths. It operates on a relentless metronome of clocked voltage. High voltage is a 1, low voltage is a 0. That's the whole shebang. There are absolutely no hidden, proprietary corporate seed tables here. It leaves behind a perfectly verifiable, globally consistent digital receipt.
Now, the crucial challenge is, how on earth do we connect our wonderfully messy, abstract human minds to this perfectly rigid machine? We build what researchers call a semiotic bridge. We use strictly formatted structured text, things like JSON or C code, to safely compile all of our fluid intent directly into exact physical ALU hardware execution.
By bypassing the gambler's messy guesses and relying entirely on the ALU surveyor, we achieve something genuinely incredible. We actually restore Noether's theorem to our computer systems. In physics, this principle of symmetry basically means reversibility. It means we finally bring exact mathematical reversibility back to our digital lives, a true mathematical undo button for reality.
Baking this absolute, unyielding determinism right into the silicon finally makes a true forensic digital autopsy possible. By eliminating the guessing, we actually reverse that wood chipper effect. When critical AI systems fail, we can freeze the whole thing and trace every single decision backward on a mathematically absolute path. We finally have a body to examine.
So, as we hurtle toward an AI-driven society tasked with massive real-world stakes, we face a monumental choice. Will we keep building our future on a foundation of chaotic hardware guesses that shatter reality into spooky quantum illusions? Or will we finally demand the unyielding truth of the ALU surveyor? What does a universally accountable, mathematically exact digital future look like to you? Thank you so much for joining me on this explainer. Keep questioning the systems around you, and I'll catch you next time.